the insulation class of electrical motors. How is it defined? What does it mean in practice? Definition of class temperature. 20,000 hours is the calculated lifetime when continuously operating at the maximum temperature of the insulation class. For example, if operating temperature is 180 degrees for insulation class H. That is how the temperature classes of insulation systems are defined. Class H insulation and Class A temperature eyes of windings. Meaning, the insulation system is designed for 20,000 hours at 180 degrees, but the motor will only reach a temperature of 105 degrees, when operating continuously within maximum permissible ambient temperature. 4.2 million hours or 479 years is the theoretical lifetime of a Class H insulation operated at Class A. Temperature 105 degrees Celsius equals 65 degrees Celsius over temperature of winding plus 40 degrees Celsius ambient. Class A temperature 221 degrees Fahrenheit meaning 149 degrees Fahrenheit over temperature of winding plus 104 degrees Fahrenheit ambient. Class H insulation and Class B temperature eyes of windings. Meaning, the insulation system is designed for 20,000 hours at 180 degrees, but the motor will only reach a temperature of 130 degrees, when operating continuously within maximum permissible ambient temperature. 740,000 hours or 84 years is the theoretical lifetime of a Class H insulation operated at Class B. Temperature 130 degrees Celsius equals 90 degrees Celsius over temperature of winding plus 40 degrees Celsius ambient. Temperature 266 degrees Fahrenheit meaning 194 degrees Fahrenheit over temperature of winding plus 104 degrees Fahrenheit. For comparison, Class F insulation and Class B temperature eyes of windings. Meaning, the insulation system is designed for 20,000 hours at 155 degrees but the motor will only reach a temperature of 130 degrees, when operating continuously within maximum permissible ambient temperature. 113,000 hours or 13 years is the theoretical lifetime of a Class F insulation operated at Class B. Some facts to consider: we are defining 40 degrees medium temperature as basis, just for safety reasons. General sewage or rainwater have a temperature of 15 to 20 degrees and probably 30 degrees in tropical countries. This is increasing the lifetime and provides 10 to 20 degrees as additional safety margin. Thanks to the very efficient cooling of our submersible motors, it takes long operational time before windings reach their final temperature. Long time means, for example, for a large motor about 8 hours. Generally the motors have some excess power against the power demand of the hydraulic, so we will never run the motor at full load. The overtemperature of the motor windings is depending on the load. The flow of wastewater into a pumping station is not continuous, but depends on the daytime, the weather and many other things. Wastewater pumps must be selected to be able to pump the peak inflow, meaning they are over-dimensioned for the average load. In reality, these pumps are operating between some minutes to probably 2 hours, before they stop and are restarted after the sump has filled with water again. This dimensioning for the peak load is also reflected in the typical operation hours. Pumps in network pumping stations operate about 1,000 hours per year. Pumps in terminal pumping stations operate about 1,500 to 3,000 hours per year. Pumps in inlet and outlet pumping stations of treatment works about 2,000 to 4,000 hours per year. For storm water pumps, the operational hours are varying very much year by year. Maybe they are 0 for 1 year and probably 200 hours per year for another year.